In this example, I'm going to go through and explain how to do our in-class worksheet problem number 3 from chapter 8. So this is chapter 8 in-class examples problem number 3. For many years, businesses have struggled with the rising cost of healthcare, but recently the increases have slowed due to less inflation in healthcare prices and employees paying for a larger portion of their healthcare benefits. A recent Mercer survey showed that 52% of U.S. employers were likely to require higher employee contributions for healthcare coverage in 2009. Suppose that the survey was based on a sample of 800 companies. Compute the margin of error and a 95% confidence interval for the proportion of companies likely to require higher employee contributions for healthcare coverage in 2009. So in this scenario, we are dealing with proportions, and we are being asked to calculate something, a confidence interval with proportions. And so there's only one formula that we have for confidence intervals with proportions. So I'm going to go ahead and write that formula down. So we're going to have P bar plus or minus a critical z-score or a z-score that's associated with the area in a single tail. And then we have our standard error formula for proportions, P bar 1 minus P bar over n, and all of that is underneath the square root symbol. So in this scenario, we don't need very much information. We need to know a P bar value, we need to know a z-score that corresponds to the confidence level that we're working on, and we need to know our sample size. So from the given information, the P bar is going to be the survey results. And so we have 52% that we're requiring those higher contributions. But remember that for P bar, we don't want to use the percent version of our number. We want to convert that to a decimal. So make sure you're using 0.52 as your sample proportion. So that's going to be our P bar value. The sample size, they did a sample of 800 companies, so our value for n is going to be 800. And the last number that we need is the critical z value. And so we have, again, 95% in the middle. Seems to be a favorite confidence interval. So that's going to leave us that 5% in both tails. So we're going to have 2.5% in the left tail. We'll have 2.5% in the right tail. One of the things that we read about as we went through the second example was the t-distribution. And when you read that section in chapter 8, they will talk to you about how the t-distribution, although it looks very much like the z-distribution, they are not exactly the same. But if the sample size gets extremely large, then you're going to see those graphs actually match up and look exactly the same. Now this is helpful because when you're trying to find that critical z value, we know that the t-table was providing those exact numbers. We didn't have to go through our look for the area in the tail, try to find the number that's closest to it in the table, and go through that entire process. So it would be really nice if we could use the t-distribution table to help us find a critical z-score, and we can. If you notice on the very last page of the t-distribution table, there is an infinity degrees of freedom. Degrees of freedom, remember, was attached to sample size. So if your degrees of freedom is infinitely large, that means that's the largest sample size you could have. And at that moment, that's when your critical t and your critical z-scores are going to be exactly the same value, which means that we can use our t-distribution table to actually find all of our critical z-scores if we use the infinity row. And so that just requires us to look up the area that's in a single tail. We travel down to the infinity row, and look, there's that 1.96 value that we used in example number 1. So we have our value for our z star ready to go. All we have to do now is take these three numbers, substitute them into their correct locations, and use our calculators carefully. So we're going to start off with our P bar, so 0.52. We're going to add and subtract the critical z-score, 1.96. Then we have a big square root. We're going to have 0.52. Then we have 1 minus 0.52. And that multiplication is being divided by our sample size, which is the 800. Again, the area, or the calculation that's to the right of the plus minus symbol is your margin of error. So when you type in all of this, and you don't need to worry about any special parentheses here, except to make sure all of this stays underneath your square root, you should be able to get a margin of error of 0.0346. So make sure you try that. And that was the first thing that they wanted to know, is what is the margin of error. So the margin of error for this study is just a little bit more than 3%. We're going to continue on to the confidence interval, so we're going to continue with our addition and subtraction step. So we're going to take 0.52, we're going to subtract our margin of error of 0.0346. That will give us the low end of our confidence interval, which is 0.4854. Then we will take that 0.52 and we will perform the addition with our margin of error, 0.0346. And that will give us a high end value of 0.5546. Again, on a printout, you'd be finished right here. This is your confidence interval. When C is equal to 0.95. But let's go ahead and write ourselves a sentence so that we know how to interpret this scenario, which is exactly what you would be doing if you were a statistician working in a company. They would pay you for not only your ability to work through formulas, but to also put it into words that others can understand. So we would start off with our confidence level. So I am 95% confident. And remember, we're always talking about a population parameter, but this time we're not talking about the population mean, we're talking about the population proportion, the percentage of people that believe something or are doing something. So we are 95% confident, the population's proportion, and then you bring in the scenario. So this scenario, they were looking for the proportion of companies likely to require higher employee contributions for healthcare coverage in 2009. So I'm going to bring that entire wording into my interpretation sentence to give it some meaning. So the proportion of companies likely to require higher employee contributions for healthcare coverage in 2009 is between, and this is where you bring in your values. You are allowed to switch back to percentages if you feel like your audience is able to understand those a little bit better and it's a more natural way of communicating. So I'm going to do that. So instead of writing 0.4854, I'm going to multiply that by 100 and make it 48.54%. And I'll do the same thing with the high end value. I'll go ahead and multiply that by 100 to switch it into a percent. And then we have our answer. So I am 95% confident the population's proportion of companies likely to require higher employee contributions for healthcare coverage in 2009 is between 48.54% and 55.46%. And that's how we do a confidence interval using our proportions.